When you look at a massive drilling rig, you see the steel, the power, but deep inside, there's a hidden circulatory system constantly at work. It's the rig's lifeblood, and today, we're going to follow its incredible journey from the heart of the rig, deep into the earth, and all the way back again.
So what exactly is this lifeblood? The single most important, constantly moving part of the whole operation. It's not the giant drill bit. It's not the derrick towering over everything. It's something you'd probably never expect.
It's called drilling mud. But listen, this is not just dirt and water we're talking about. This is a complex, highly engineered fluid. It's a precise cocktail of solids and liquids, custom-made for every single job. It really is the unsung hero of this whole process, and its journey, it's pretty amazing.
All right, so where does this journey start? Well, just like any circulatory system, it all begins with a powerful heart that gets everything moving.
Meet the mud pumps. And yeah, if they're the heart, they are definitely the muscle of this whole operation. They provide an incredible amount of power to move all this fluid at exactly the right pressure and volume. Now, there are a couple of different designs out there, but one type really dominates the modern rig.
So how does the most common one, the triplex pump, actually work? Well, it's a beautifully simple and powerful cycle. First, you've got this plunger that drives forward, squeezing the mud until a discharge valve pops open, forcing the fluid out. Then, as that plunger pulls back, the valve slams shut and a suction valve opens up, refilling the cylinder for the next power stroke. And this just happens over and over and over, generating unbelievable pressure.
The main difference in pump design really boils down to this. That triplex pump we just talked about is single-acting. That just means it only pushes mud out on that forward stroke. Its older cousin, the duplex pump, is double-acting, so it actually discharges fluid as its piston moves both forwards and backwards. But really, for sheer power and efficiency, that three-cylinder triplex is the king on modern rigs.
Okay, so our mud has been pressurized by the pumps. It's ready to go. Now the real fun begins. Its incredible, high-speed journey from the surface deep down into the earth. Now, the first part of the journey is actually up. Kind of weird, right? The mud is forced up this huge vertical pipe called the standpipe, which runs right up the side of the derrick. It's got to get all the way to the top before it can start its big plunge down. From the top of the derrick, the mud gets shot into the drill string. And you can honestly think of this thing as a miles-long steel straw. It's the main highway that carries that high-pressure mud all the way down the well to the drill bit at the bottom.
After traveling thousands and thousands of feet straight down, the mud has finally arrived. This is it. This is where it does its most important work. This is the main event.
And this really gets to the most important question. Why go through all this trouble? Well, because this mud is an absolute multitasking superstar down there. It's not just flowing, it's blasting rock cuttings away from the bit, it's controlling insane underground pressure to prevent blowouts, it's cooling and lubricating the entire assembly, and it's basically plastering the walls of the hole to keep it from collapsing. It's doing like a half dozen critical jobs all at the same time. So, with its main job done, the mud's journey is far from over. Now it starts the long, much slower climb all the way back to the surface. But it's not coming back empty-handed.
The path it takes back up is called the annulus. It's just the space between the outside of that drill pipe and the wall of the hole. So the mud, now loaded up with all that ground-up rock and debris, flows up through this channel, carrying its payload back to the top. Once it finally reaches the surface, the mud flows out of the well through the mud return line. Think of this as the off-ramp that guides all that dirty fluid towards the next and final stage of its journey, the cleaning process.
Now, the mud has done its job, but it's expensive stuff, and right now it's full of junk. You can't just pump it back down. First, it has to run a cleaning gauntlet to get recycled and ready for its next trip.
First stop is the shale shaker. Just think of this as brute force cleaning. It's basically a big, vibrating screen. As the dirty mud pours over it, the biggest rock cuttings just get shaken out and tossed aside. This is the first and roughest line of defense.
With the big chunks gone, the cleaning gets a little more high-tech. The mud is sent to the desander, a machine that uses pure centrifugal force. It spins the fluid at incredibly high speed to sling the heavy, abrasive sand particles out.
And the process gets even finer at the desilter. It's using that same spinning trick, but this one is calibrated with more precision to target the next smallest problem: tiny particles of silt. You got to get these out, because they can cause a lot of wear and tear on the pumps.
The final and most intense stage of this cleaning gauntlet is the centrifuge. This machine is a beast. It spins at incredible speeds, creating immense force to separate out the very last of the unwanted solids. What comes out the other side is clean, rejuvenated mud, finally ready to start its journey all over again.
And that, right there, brings us full circle. After one last stop in a settling pit, just to let any leftover solids drop out, the clean mud is sent back to the suction pit right next to the mud pumps. From there, it's ready to get picked up and start the whole circuit over again.
Now think about this. This entire cycle runs nonstop, 24 hours a day, 7 days a week, for weeks or sometimes even months on end. It is the constant heartbeat of the rig. Which leaves us with one pretty crucial question. With everything depending on it, what happens when that lifeblood stops circulating?